is let's go through our lesson 3 and see if we can do the exercises as well. Okay, but let's just go through it. So we're making these lists. Okay, and we see this list, and you can put numbers and words in it. It's strange, right? So, okay, so we can even add an extra word. Do Shift Enter, and there we go. So we've added Sterling into my list. And you can have two different lists. So let's see what happens if we put. So we go into our input, and we say, well, let's add Sterling as an element before Mathematica. And we see that we have a list, but they're slightly different. Okay, and let's see if it's still true. Are they equal? No, now they're false. Okay, so they're false because of Sterling being in a different place. So let's see if we can get it back to the way it was. So put in Sterling in the second spot. Okay, now let's compare my list with my list 2. And it's true once again. And we can use an equal. So you can use the signs, or you can actually use the function. Okay, and that was a question whether you could just use plus 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 or use the function. Now here's an interesting thing, is a double equal sign are the same. Like 0.1, 0.01 are the same. But are they the same type? No, and so this is the computer saying, hey, 3 is an integer, it's a whole number. 3.0 is a decimal. And the computer treats them differently. So the three question marks actually is this same Q, same Q, same type. Okay, so I'm not sure why it's a Q. Okay, and so here he's just getting fancy. He says, look, we can say they're not the same type. Okay, so if we take away the 3.0, now it's false. They are the same type. Now here's a weird thing. So let's see what happens if we say double it. Okay, so not really clear. So with the numbers, it knew what to do double, but the 2, it just kind of put it in there with it. And so you suspect, well, what if I say 3 times this? So just playing around, say 3 times that, and yeah, so it just says 3 times Sterling. Okay, so we multiplied everything by 3, so let's see what happens if we add 3 to everything. Okay, so we should get, so we add 3 to everything, but remember, we didn't change the value. So think about what happens is that we multiplied my list by 3, but we didn't save that as a change. So that makes me wonder if we can do this, if we can do my list 3, you can use an assignment statement. Let's see if that works. So let's create a new list that is that triple thing. Okay, so it looks like it works. So now let's add 3 to my list and see what happens. So what we're hoping is that we get 6. Yeah, we do. Okay, so we made the changes to my list and we stored it in my list 3, and then we added 3 to that. Okay, so you might say, well, can you keep doing this? So you say, yeah, I can. So my list 4 equals, so this use of equals is this an assignment statement. So we say we want to have a new my list 4 that shows us this. So then we'll say, okay, well, what is my list 4? Okay, and we'll see if it'll print it out for us. And it does, right? So it still has that 6 in it. Whereas if you print out my list 3, it didn't get changed by that operation. It still has a 3, 6. Okay, so can we still multiply them together? MyList 1 and MyList 2. Let's see, I'm not sure. Yeah, so we can, and we get MyList squared. Okay. Now, let's say that we put it into MyList 5. Say MyList 5 equals this. Let's see what happens. Okay. So we do this, and now we say, okay, I've got this new list, MyList 5, and when we look at it, it has the squared in it. Okay, so it has 1, 2, 3, 4, 5 elements. Okay, and so now let's see what happens if we do MyList 5 times MyList 5. So can we do that? Okay, so now you can see what happens, right, is we get, now we have everything to the 4th power. And so we can create a MyList 4th power. So let's do MyList 4th power. So we create that, and we say, okay, let's run it. So now, you can guess what I want to do. I want to display MyList 4th power. 4th power. So let's display it, MyList 4th power. And what if we say MyList 4th power times MyList 4th power? So you can imagine that we're probably going to get 8th power. So we get 2 to the 8th, 3 to the 8th, Mathematica to the 8th, Sterling to the 8th. Now I kind of wonder, well, what would happen if we added these? So let's copy this over, and we'll put that in a new thing, and we'll say, okay, instead of multiplying MyList 4th power, let's add them up. Okay, so we'll add them up, and we'll get, okay, so we had 11681, now we get 232, 162. So we're able to add them up, and we get 2 Mathematicas to the 4th. Okay, so we can make a list of lists, and in fact, I suspect what you can do is you can make, if we go back and we copy this MyList 4th power plus MyList 4th power, right? So we'll try and let's try this. Let's try to MyList combined. So MyList combined equals a list, so we put that inside the square brackets. List, first list, and the equal sign, and the second list. And we try and execute that. And there we go. We sort of doubled that up. Now let's work on our matrices a little bit. Okay, so it turns out that this is one of the things that as you go further in math gets used a lot. And I never was too good in it, but I recently took a course, and I had to stop taking the course in machine learning because I didn't know enough about using these matrices. So I wish that I knew more. Okay, so we set up this matrix, okay, and we have, you might say it's a translation of this. So it's row 1, row 2. Okay, so it displays its data in terms of rows first. Okay, so, and that's something that isn't a given. There's other systems in which you do it by columns, in which you would have done 1, 3, 2, 7, and you would have known that there are columns. And so this is what they're talking about. They're doing it row-wise. Okay, so there's then some talk about different notation you can use. And so what you can do when you're displaying something is say, okay, let's do matrix form. Or you can say afterwards, you can say, okay, here's my matrix, and I want to display it in matrix form. Or you can use it as the full function. And so now that we've done it, let's see if we can create our own matrix that's a little more complicated. And so we'll copy this one and say, we want to do a matrix that is 3 by 3. Okay, so let's give that a try. So let's do 1, 2, 3. And then they'll just help us to see where stuff is. So let's do 4, 5, 6, 5, 6. And then let's do one more row of 7. So we do it. So it's a list of lists, 7, 8, 9. So we need our closing curly brackets there as well. So let's try that. Okay, so we create our matrix. And now let's see about the different ways we can do it. Oh, and unfortunately we named it my matrix 1. So let's rename it to my matrix 2, and then let's execute this one and make it my matrix 1 again. All right. So now let's see what we can do with this. So let's do our matrix form, and then we do the @ my matrix 2. Okay, and there we go. There's our 3 by 3 matrix. And they have other ways you can do it, but so we could also just do matrix form, and instead of that @ so it doesn't save you that much, right? You still got to just put your square brackets around it. Oh, not that square bracket. And say, okay, there it is, and we get the same thing. Okay, so now can we add 3 to everything in our matrix? Okay, so let's give that a try. Okay, so let's go down. We'll go down here. Oops, that will fit. Squeeze in something there. And so let's take our my matrix 2, and let's add 3, and that should add 3 to everything in it. So instead of 1, 2, 3, 4, we should see 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now, when you think about it, that's a very powerful command, isn't it? So it changed 9 cells with just saying add 3. It added 3 to everything. Okay, so now we want to get into this idea of I can I can use the table command to create a list. So let's try let's try and create a table that has a little bit more to it. And so we use this and we say, okay, we're going to use an iterator I, so we're going to go through by I, and we'll give a set of instructions. So we say, let's go from I equals 1 to 100, but let's iterate by 0.5. Okay, so we should have 1, 1.5, 2 all the way up. So we should get about 200 in our set. So you see that Wolfram doesn't care, right? The computer will do what you ask it to do. So it's more than happy to generate a big table. And you can see it did something strange. It left 69 point, right? So yeah, it went by 0.5. So it was interesting how it did that. Okay, so if you look and say, well, what does it do if you don't put in the iterator? Then it assumes that you need to go up by 1. And it assumes that you start at 1. Okay, so we don't have to start at 1, right? We could start at 0. And it'll start at 0. And let's see if we could start at -10 and go all the way up. And it's happy to do that as well. Okay. Okay, so we could go backwards. And so what we could do, and we could say, well, can we do that in ours? So what if we started at 100 and we went down to 1, but we went by minus 0.5. So we went down from 100 down to 1. Let's see if that works. And that seems to work as well. So we got 100 all the way down. Okay, so you can do squares as well. And so we could do my table cubes and say, well, we're going to do a table of cubes. And so we do our table. And we say, well, we want to do I to the third power. And we're going to do, well, so let's just, for last, let's just do 1, 5. And let's make our, let's go up by 0.5. And so you notice that I got an error there, so I didn't put in the variable I, so I sneaked that variable in. And now let's see if we do it. And so it does go up. And so it should have, what, about 8 in there, 1, 2, 3. Yeah, so it has about 8. It has, again, that strange thing that it puts that extra point there. But we see that we have the cubes of 2.5, 3.5 as well. Okay, so then you say, well, it looks like we can make a table that has I and j. And so we got a pretty interesting one there, right? So we add I and j, and we have this nested form. Okay, so a more common one is really, so let's do, let's see if we can do a checkerboard. Okay, so we go in here, so we're going to try and do a checkerboard. So we do my table chessboard, let's call it that, chessboard, and it equals, so we want to see is if we can get A1 through H8. Not sure if we can do that. I plus j. So we say, okay, we want to iterate, and so we're going to try it, and I might not be able to do this, so I'm going to go I'm going to go 1 to 8. Oh no, actually we want A, yeah, so we want A to go A to H. Let's see if it'll do it for us. Okay, you never know till you try. And then our other list variable is going to be j, and it's going to go 1 to 8. And so we say, well, are you going to do that for us? And what it says is, well, you don't have appropriate bounds. And so that didn't work. So I have to think about how we can get the chessboard to come out with all of them. So I remember we did something in Wolfram where we had all the combinations from AA to ZZ. So we had AA, B, AC, all the way to AZ. So there's a way, I just can't remember it right now. It happens a lot with Wolfram. Okay, so now, what if we want to print different elements? So the first syntax I use is the second element is this double thing. So if we do with 2, it prints out 2. If we print out 4, it prints out Mathematica. And so they have another thing called a double bracket there. Okay? And so if you go to insert and you do special characters, we see a double bracket and a double bracket. And so let's see if we can insert that up here. So we say we have our double bracket, and we'll put a 3 in there and see if we can print out the third guy. And it is. We are able to print out the third guy. So you can insert that from this insert special characters, the common ones there, and there's that double bracket. Okay, last item in the list. It's nice to be able to do that with -1. Okay, so we'll go back up here and say, well, we also had my table TK, right? So that's a long list. And the last element in it right now is 1 point, right? So it went downhill from 100 to 1. So let's see if we can get that one to work as well. Okay, so we go in here and we say my list TK. Oops. So notice how we don't find that name, so we better double check and see that we, oh, my table TK, okay. Okay, so we want to do my table TK. And we say bracket, bracket, -1, bracket, bracket. And we expect to get the 1 out. So there's our very last one. And remember, we could do other things. I'm not sure how you get the second to last element. Okay, we can get the 50th. We just say that, well, there's the 50th. Okay, so what they're saying is we've got this nice matrix, my table 3, and we can, if we ask for the first element, it gives us the first row. Okay, if we ask for the second element, it gives us probably 4, 8, 12. Well, that's strange. So it seemed to work fine. Oh, so maybe something. Maybe we haven't executed my table 3. So maybe I messed that up. So let's just go. We had that nice matrix that we made, the 3 by 3, my matrix 2. Okay. So let's see if we can just use my matrix 2 and see if that works. My matrix X 2, and we want the first element. Okay, 1, 2, 3. My matrix second element should be 4, 5, 6. I think, yeah. My matrix 3 would be the. So there we're going by the row, and then you just kind of wonder, well, you know, can I do? So sometimes the syntax is like this. Can I do the first row, first column? Okay, so it doesn't like that. Then you say, well, can I do this? 1, comma 1. Okay, no, I do that. So I try that. Yeah, so it'll do that, 1, comma 1, 1, comma 2. So different languages have different syntax. So now you're saying I want to go to the first row. So you can go, say, to the third row, second element. Okay, so you can do it that way. Okay. Yeah, so then they're showing you that same thing. Double semicolon states you want all the elements. Imagine you want all the elements in column 3. Okay, so let's try that for my matrix. So we're going to say all So we want all in the second column. So remember it's 1, 2, 3, 4, 5. So now we got the middle column. Now we should get 3, 6, 9. If we do this, we get 3, 6, 9. Okay, so we can do all like that. Okay, or we can do a double semicolon. Okay, semicolon, semicolon that says, for each row, give me the third one. And there we go. For each row, give me the second one. Okay, so what can we do? We can say, let's get the size of the list. Okay, so let's see what is, let's do my matrix 2. Okay, so there it is. And let's do the length. Length my matrix 2. Okay. So interesting, right? It's just 3. So why is it it's just 3? Well, it has 3 elements, so it's counting at the top level. So my table has 5 lists. It's a list of lists. Okay. So it's returning the sublist. Well, so now it's saying, well, what if you have even more nesting? So it doesn't care, right?